Hello YouTube. Today we are going back into the neural network module. I completely finished it, but only for ANNs or quote-unquote normal ANNs, where there is a sigmoid activation. Well, I mean, you could use ReLU activation and prime, but we have all the basic stuff that you would learn. Added a global variable that determines the D-type that you can implement, and let's run it. Wait, first, let's run this unmodified compared to last time. You may already see the time, but that's not accurate for all devices, as this is not the most optimized. But it works pretty fast compared to, well, I don't know, it just works fast-ish. For 500,000 iterations. Finished in 30.2 seconds. And for cells.py, we have all of this code. You would expect it to be a bit larger because you have cells, unknown cells, hidden cells, set cells, cells in general. And you have this whole network set out, or network layout. And it just doesn't seem to be too optimized. Sorry. So let's try it out. I also added this so you can shave off a couple milliseconds to the end time. It just computes the stuff going on. The accuracy isn't important in this run. The time is important. They have the same processing. But look, I optimized it and now it works in 26.8 seconds. That is a near 10-second reduction. Or no, I'm completely wrong. A near 5-second reduction. And running this on my Mac, it seemed to be accurate. This would take around 27 seconds, and this would take around 21 to 22. So, let's see what it's comprised of, and what I will add. Here we have the author stuff, and D-type, a built-in function that creates the D-type of a name. ToList converts matrix to a list. ToMatrix converts a list to a matrix. Add matrices, or add matrix. It just adds matrices, I guess. Matrices, I don't know. Some matrices, it does this, but with a whole list of them. Random matrix, it just creates a random matrix. Who knows? Roll random, it just creates a random seed for numpy. Label, it just labels stuff and returns the confidence. Softmax, it is, well, these are all of the activation functions. I took a while implementing them, and I switched them out from using lambdas because of something else in the code. So, softmax, I really need to work on getting a prime. I couldn't find an answer or an actual prime, or a good prime. More of class layer. It is a layer object. It is the default layer object, so you can modify it. It has, and it just takes a cell and a dimensions. And, okay, other stuff. It also supports D-types, so forward propagation, back propagation, I built all of these methods into the layer so that I can modify it to get a different layer, like a pooling layer, I guess. Yeah. So that they would be a semi-compatible network. It just holds a bunch of layers. And it does the stuff with the forward propagation. I should probably switch this out for this. Instead of this. I mean, it doesn't make much a difference. It's just something there. And configure weights just adds on to the weights using the layers method. I had an error here that got me caught up, but then I realized that you don't need in order train. It just does all of this stuff. If this is true, then it returns errors. And this is why I turned the lambdas into functions. Save, it saves to a pickle file, .pick, P-I-C-K-L-E. Yeah, pickle file. And it just saves everything in this to the pickle file. It loads the stuff from the file and updates itself with that. Cell, it's just a base cell that needs to be used as a subclass, or it needs to be used as the base class for a cell you pass to a layer. So you can create your own cells. That cell, it just returns the value depending on the previous RNN cell. It is an attempt at an RNN cell. I still need to work on the prime, and I don't have the prime of softmax, so that's an issue. Hidden cell, it is just a regular cell. I might want to call it regular cell or something like that. But that's it. Main, this is just what would run if you ran this by itself. It would default to float 32, tell you information, create 2 layers going from 3 input nodes to 6 hidden nodes, 6 hidden nodes to 1 output node, 3 input nodes on each one of these, and 1 output node. Also, I did something so that as it keeps on running, the efficiency actually changes, so it takes drastic first steps when it doesn't know what's going on, and smaller steps when it starts to understand stuff. That's why this is pretty accurate. So, like, that is a 99% confidence. 99.99%, 99.99, not including rounding, % confidence. And in general, it's pretty confident. Then this, if it runs, then that. And I made a small thing. I'm working on convolutional nets, so hopefully that comes out soon. And more just optimization. I have a network. I set up the network from the layers, 4 input nodes for a square, 22 hidden nodes to 5 output nodes. And these output nodes correspond with these. If I run this, I forgot to change this. It takes a while, and I didn't add any, well, in processing running, so but I mean, for what is the iterations? For 200, yeah, so for 200,000 iterations, that's pretty good. Pretty good confidence, and it lines up. Whole, corner, corner, horizontal, corner, vertical, diagonal, corner, corner, diagonal, vertical, corner, horizontal, corner, corner, whole. Same here. You can pause the video and check that out. I'll be releasing this soon after I get CNNs to start working, not the news network, convolutional neural networks, and that's about it. See ya.